Alrighty, the long-awaited Golang tutorials. I'm super pumped. I transparently have only done minor experience with Golang, just building out some orders APIs and things like that. But I needed help. I still need help understanding a lot of Golang. So I'm actually really pumped just to break it down, get to the basics, just iron it out line by line with y'all. So it's going to be a good time. So first of all, welcome to Learn Go. I've taken like 4 of these, and I was like, wait a sec, I need to record these. What am I doing? What am I doing? Okay, so we're at the introductory bits of Golang. Let's just talk bird's eye view before we dive into the actual tutorial here. Why do we want to learn Golang? It's a statically typed language that's it's above Rust and C++, but it's faster and more performant than dynamic programming languages like a JavaScript or Python. So it's really growing in popularity with API development and microservices specifically. If we looked at LinkedIn job applications and stuff, it's becoming more prevalent on certain jobs. Let's see if I can see Golang engineer. I think it's just a wise thing to have under the toolkit. I would not recommend this as a first language per se, but let's see. Boom, Golang engineer. Here's one that you guys are going to see this real quick. Let me try to remove some of this stuff right here. Boom. Okay, so we have a Golang engineer right here. Here's some experience. Here's engineer full time. I'm sure it mentions Go or Golang. Let's see, Golang, boom, or Golang, boom. Founding engineer positions. Let's see. What's the company name that I just did an interview for? Their entire microservices were built in Golang. Let me try to think of it. Oh, Lightspeed System. Amazing company, by the way. Amazing. I didn't get the job, but very amazing company. Great team. Really solid people, but their entire backend is built in Golang. So, and they have like 60 million requests a day, I think, or something like that, or a week. They do a tremendous amount of e-learning stuff. Brilliant team, as mentioned. But the biggest thing just to highlight is Golang is one of those defining languages of like, okay, this guy's not really a junior engineer necessarily, right? Kind of that JavaScript, that front end, HTML, Python, if that's like all your toolkit is, you should still hone that in. There's still a ton of damage you could do with those languages. In fact, they're still the bread and butter of very many systems out there today. But when you start tapping into performance and trying to get more performance stuff and lower latency, Golang's not the best on that, by the way. You certainly want to go with like a Rust or things like that, but it is really good with concurrency and still performance. It's tremendously faster than TypeScript, especially when you have like 1,000 clients plugged into a computer. Golang is significantly faster. The reason why is because it's a statically typed language. So some of this stuff, performance and all these things, don't really matter when you're on your local machine. It doesn't really matter if you have 5 users. It doesn't matter if you have 100 users. But when you start diving into these larger systems with 1,000 people, 15,000 people, 100,000 people plugged into your system doing 1,000 requests, a day or something, or 100 requests a day with all their, actions and activities, all of a sudden you need to understand a more performant option. So that's kind of bird's eye view why we want to learn Golang. But let's dive in. That's you can hear my oven going off. Let's dive in. That's obviously, the big reasons to it, but outside of, it helps the salary, helps the position. It's part of, I think, any performance. I don't want to say all backend engineers' skill sets, but certainly it was something I heard at Babson as well. Was one of the leads was talking. He was one of the principal engineers there. He was very much a Golang user, or had it part of his toolkit. So if he's got it part of his toolkit, I want it part of mine, right? So let's dive in. That's kind of the nitty gritty of it all. That's gaining popularity a bit. Yeah. So let's not iron out too much more. But basically, the nutshell of what I understand of Golang is it's faster, better for backends, and they have Golang frameworks for backends like Chai, and there's a few others, I think Gen, and a few other backend frameworks for Golang. But overall, it's a wonderful thing to learn. So we're going to do that. Welcome to Learn Go. The course assumes you're familiar with programming basics. Do not learn this if this is your very first language. It's going to hurt your head and be very frustrating. It hurts my head and it's very frustrating. So if you're new to coding, check out the Learn Python course or watch some JavaScript kind of introductory videos. There's some good ones with Alchemy and Code with Mosh. He's a wonderful guy as well. Okay, so booting up the Textio server, all the code you right? This course is part of a larger product, an SMS API called Textio. Textio sends text messages over the internet, so we're going to make a Twilio clone for SMS messaging, some sort of API. Beautiful. So assignment log starting Textio server to the console instead of hello world. So I actually deleted some of the code here, but what we're going to do is import this FMT package, and what that is FMT, and then I think print line is their console. So let's run it. Let's see if that works. Starting Textio server. Let's submit. Oh, let's see. Correct. I don't get the splash screen because I've already done the first 4. So let's go ahead and go forward. Don't touch above this line. Don't touch below this line. I vaguely forget the bug, but what it is, I think it was this potentially. I think is what it was. Please ignore this guy. How do I turn this off for this whole turn off Grammarly for boot.dev? Yeah, let's just turn it off indefinitely for boot.dev. Okay. So this is how Golang assumes a type. So typically in like Python or JavaScript, right, we could say this is my variable, and I'll say my variable is number 1, right? In Python, I could just say my var is number 1, right? And both of these are dynamic, JavaScript and Python, and they'll kind of assert the type. But with Golang, if we actually wanted to say my var, we'd say var, my var, and we'd say int 32 equals 1. And it's a lot more granular, you could tell, but what Golang doesn't do, it doesn't assume the type of the variable unless we do this, unless we do the syntax for it, which is this. Boom. And that will assume that it's an int or some sort of float or something. While in TypeScript, we would have to define it as number. Python, I'm not even sure if you get types with Python, but yeah, in TypeScript, we'd have to, the equivalent in TypeScript would be something like that, where we would define it as number like that or something else. But Golang, a little bit more granular, as you can see. But if we want to assume the bug, or excuse me, the type of the variable, we'd add that colon. So I vaguely forget, I think that's what the bug was here, but we'll just run it. We're going to keep moving close. Okay, you're only a few characters off. Let's see. So cost per message, probably need a float. Number of messages, let's see. So we could probably make it a float here. I think that'll fix it. But we have to be very careful with our types. Let's see, close, you're only a few characters off. What are we off on? Okay, let's see the solution. Oh, it's multiplied instead of, well, that's just silly. That's just silly. Okay, let's move forward. Boom. Let's see, Go code generally runs faster than interpreted languages and compiles faster than other compiled languages. So, okay, so it is faster for compilation. Maybe not at runtime, but for compile time, it's faster than this. And the reason is because it's static, right? But I thought C and Rust were static as well. So does Go generally execute faster than Rust? The answer is no. Let's click yes again just to see. So as mentioned, there's definitely more performant languages the closer you get to the hardware. So let's see. So Go is generally faster, more lightweight than all of these: Java, PHP, Ruby, Python, JavaScript. But in terms of speed, there's still a few faster ones, which is Rust and C++. If you want to learn that stuff, I would just go with Rust at this point. I think C++ is going to be roughly deprecated and replaced by Rust. So maybe we'll tackle that. I wanted to build some Solana nodes at some point, and obviously Rust is very much on that what's it called, that ecosystem. So, but Rust is just, it's a beast to tackle. Okay, so the compilation process. Computers need machine code. They don't understand English. They want things to be compiled down to bytecode. So the Go's compiler job is to take Go code and produce machine code. On Windows, that would be a .exe. On Macs, it would be Mac or Linux would be any executable file. The code you write in your browser here on boot.dev is being compiled by boot.dev servers. Then machine code is executed on your WASM browser. Wonderful. So a note on the structure of a Go program. We'll go over all of this, pun intended, later more in detail. But to sate your curiosity for now, here are some tidbits about the code. Package main lets the Go compiler know that we want to use this code to compile and run as a standalone program, as opposed to being a library that's imported by other programs. The main function is it's like a constructor for Go. It gets fired off. The FMT is formatting package that exists in Go's standard library. And Go is super interesting. We can import stuff from GitHub too, and we could also put our package up to GitHub, and that's how we like route to other packages. It's super interesting. We're gonna learn a lot about Go. So to pass this exercise, fix the compiler error code in the code. I think it's fixed. Did I do this one? Print line. Oh, we're just missing a closing parenthesis. And let's get moving. Oh, okay. So do computer processors understand English? Open the browser. No, they do not. They understand bytecode. Okay, so to run a compiled program, users need the compiler, the compiled executable. Let's go with the next one. So which language is interpreted? Jeez, I want to say Python out of these. Oh, sweet, it is Python. Wonderful, wonderful. Okay, so Go is strongly typed. It's very strongly typed. I use TypeScript regularly. In fact, I have only used TypeScript for the last 18 months, I would say, for any professional work. And Go still pisses me off, you know. And I love TypeScript. I love typing things, but Go is very particular. Okay, so it enforces strong and static typing, meaning variables can only have a single type. A string variable, hello world, cannot be changed into an int, such as the number 3, later on down the road. One of the biggest benefits of using strong typing is that errors can be caught at compile time, not runtime. In other words, bugs are more easily caught ahead of time because they are detected when the code is compiled before it even runs. Beautiful. Contrast this with most interpreted languages, dynamic languages, JavaScript or Python. They don't do that. You very often will find bugs at runtime, especially JavaScript. JavaScript is messy, and Python's not much better, to be honest. They're both amazing languages, but when you compare runtime and compilation bugs, it's night and day when you use TypeScript or Golang. I would argue Rust as well. I don't have very much experience with Rust, though, but I do want to get there one day. Okay, so with interpreted languages, the code must be run to catch syntax and type errors, sometimes in production if you are unlucky. That's not good. You obviously want to catch things before runtime. You want to catch it on compile time. So concatenating strings, two strings can be concatenated with a plus operator because Go is strongly typed. It won't allow you to concatenate a string variable with a numeric variable. Wonderful. So assignment, we'll be using simple basic authentication for the Textio API. And this is how our users communicate to us who they are and how many features they are paying for with each request to our API. The code on the right has a type error. Change the type of password to string. Right now it's an int, but use the same numeric value so that it can concatenate with the username. Okay, so we'll type this to string and we'll need to wrap that bow like that. I think that's all we need to do. Wonderful. So that was more of a lesson on just why Go is powerful. It's a static language again, and because it's a lot of the bugs are compilation errors more so than runtime errors. When the server gets it, it can fire off the code much quicker. Versus JavaScript, even TypeScript gets compiled to JavaScript, and then that gets sent to runtime through the V8 engine. But that's where you could experience still some errors, some hydration issues, any typical bugs you may run into. Now, Golang, you could still force some bugs on the compile side. There's still interesting ways to do that, but it's like 99% all that stuff is handled. So if your program works on compile time, 99% of the time it's going to be effortless on runtime as well. So it's not a strong percentage, but it's a vague number I've made up now. So generally speaking, which languages uses the most memory? I'm going to say Java out of these. Oh, nice. I was right on the nose with it. Let's go. Oh, let's just look at this again. Yeah, so look at Go's compile time. So Rust is still better, but when you compare it to stuff like this, and Java I think is faster than Python as well, and JavaScript. I don't know about idle memory usage, but let's see. So we'll say Python idle memory usage. Let's see, and we'll put JavaScript in there as well. See what it comes with. Idle memory usage, Python versus JavaScript. Let's just see who uses more, right? Point being, maybe we don't have to get to crazy granularities, but the V8 engine and Java, V8 Python runtime are all built into a Lambda. It's unclear how they will impact memory calculations. Interesting. Oh, he's probably talking in terms of serverless. Okay. So, but point being is if we just look at this, where like Java, Python, Ruby, these guys all hang out in the same area. Go is right next to Rust, and Rust is probably another layer of abstraction of complications to learn, but you can see how Go is like right next to it. So when you talk about efficiencies, bang for the buck, if you will, Golang is certainly worth it. Okay, so what's one of the purposes of the Go runtime? To style Go and make it easier to read? Nope. To scare off JavaScript developers? Potentially. Compile Go code to clean up unused memory. We'll go with that. We'll see. Sweet. Wonderful. But as you could just see, like the level of memory usage and even the performance charts look like that as well. When you talk about TypeScript with 1,000 users or 10,000 users making 100 requests, you get that same variance with like TypeScript to Golang. It's like Golang is like hanging out at the bottom of the chart, you know, and then you see TypeScript as like more users and requests, it like hugely goes up. So that's huge to remember because, again, on small systems, and you could still build big systems with TypeScript. There's no problem to do that still. But when you just compare speed, Rust is still going to be quicker than Golang, but it's like marginal quickness at that point. Maybe it's still worth it. But the level of complexity that Golang isn't compared to Rust, it's why it's so worthy of learning. And then also, it's just one abstraction deeper, I would say, just a little bit harder to learn than maybe JavaScript. I'm still learning it. Or TypeScript per se. I think it's a smooth transition from TypeScript to Golang, but the performance boost you get is largely worth it. Okay, so let's see. So there are some bugs in testing code used to send a message. Let's see. So this is not a string here. That's one. This is not an int here. This is a string. And boom, don't touch below this line. I think that's all that needed to be done, right? Confirm is, I see, confirmation. Boom. Okay, so function main. Let's see, fix bugs 6, 7, and 8. So we can do this, I think, to assume the types. Maybe that'll work. But if not, we'll have to, let's see. Oh, it did. Okay, so we could do that, like I said, to assume the types, or we can do the var string. And there's going to be actually use cases why you want to be very, very, very particular if you want to use which syntax, right? But let's see. I think it'll all work, which it does. Different ways to skin the cat. Wonderful. So that's the introduction to Go. We'll dive into the variables here shortly. And there's a lot to learn here with the loops, slicing, the maps. They're crazy. Pointers. And there's different things in Golang that you could do as a language. So super interesting. We'll be back for our 2 here shortly in a sec, guys. Thank you so much for learning Go with me.